Hello everyone, so in this particular video we'll go through the topic of cross entropy loss for PyTorch. So let's start the documentation. So obviously you can see torch.nn.CrossEntropyLoss. So this is used with softmax and there are many parameters over here. We will be going through all the important ones. So we'll be going through weight, we'll not be going through size average because this is deprecated. We'll be going through ignore index. Again, reduce is deprecated because that both of these size average and reduce have been compiled into reduction equal to mean, and also label smoothing. Okay, so there's a lot of theory over here. So basically this is used, this entropy cross entropy loss is used with your softmax. So I assume that you already know your theory of softmax and cross entropy because both of these theory videos are uploaded on this video on this channel already. Okay, so there are two ways by which you can use cross entropy loss. Okay, so there is one way by which you have to specify the what to say, your classes. So let's take an example. Let's say you have a neural network. There are many neurons here. Again, there is some layers, and then there are internal layers, and then there are, let's say, four output neurons. Okay, so what you will have, or let's assume five. Okay, so what you will have is basically out of every neuron you will have some output. Okay, so let these output be the norm, the not unnormalized to say your output from the neurons. Okay, so you will have certain outputs, let's say O1, O2, O3, O4 and O5. Okay, O5. So this one is O1, O2, O3, O4 and O5. So in the first case that is given over here, whatever this means, the target that this criterion expects should either contain, the first one, it contains the class addresses. Okay, so or the class indices. So here, let's say if this was correct, then the answer you have to give in ints, which I'll show you one second, is equals to for the class index, that is 0, 1, 2 and 3. So if 3 is given, which means this fourth one is selected, due to index we have to take -1 because index starts with 0. This is correct and all these are wrong. Okay, so this is how your loss will be calculated. So loss is basically your whatever is the weight. We'll assume that weight is 1 for now because there is already a weight parameter. And then what you do, you take the log. Okay, so you take the log of what, of the exponent. This is the softmax. That's why I said you need to know the theory of softmax first. Okay, so this is the softmax of that particular neuron into 1 where yn not equal to ignore index. We will see what is ignore index. Let's say there are no ignore index for this, so which means all of these values will be counted in the loss. Okay, so now what happens is you take this loss of 1, that is the one particular loss, and then you take all the losses here and then you do a transpose, or basically you take the entire loss. Okay, so basically what we do is we add, but generally in here I'm going to show you first reduction equal to none. If you remember already, let's say there are n, what to say, examples. So you will have a loss for 1, L1, a loss for 2, L3 and so on and so forth up to Ln basically. Okay, so here what you will do is you will take the losses here, and then finally so as you can see, this capital N spans the mini batch, so which basically means this one is for example 1, this one is example 2, example 3 up to example capital N. Okay, so let's get back. So this is your loss. Okay, now what you have to do basically is let's say your reduction basically over here. Okay, so first first thing that we'll be focusing on is reduction equal to mean. Okay, so let's go back to the theory. So if you have seen the sigmoid or let's say the BCE loss or MSE loss, there I have already explained what reduction is. Okay, but I'll again go through for those who have not covered it. So you see this loss over here, this L1, L2, Ln. When you say reduction equal to none, which is the first parameter, reduction equal to none, you are basically saying that I just want the losses as a vector. Okay, but when you say reduction is equals to sum, what you are doing is you are saying just sum everything, whatever losses we have found across all the batches, across all the examples in a batch, just sum all of them. Okay, and what do you think will be the mean? It's very easy. It's just again sum everything and divided by the number of occurrences, that is capital N. So this is basically what is the first you see over here, reduction equal to mean. Okay, now let's see the example a little bit. So first we will basically have our imports, and then you will have two things. Okay, what are this out? Out is basically your what to say, this is for one particular example. So out is basically, I told you, here 5 neurons are there. So out is basically this out. It is the value of all the unnormalized value. These are basic logics that have come out from these neurons. Okay, this is basically your out vector. So that is what I have represented here by 5 random numbers. Now I have taken the right index to be 2. In here I took the right index to be this 4th index, or yes, this 4th neuron to be the right index. Here I have taken right index to be 2. Okay, let me also go and show it to you. So you have to print out, which is this basically this unnormalized logits from the 5 neurons. So this is basically the output of the 5 neurons at the last layer without any activation function, and this is the second one, which is your correct target, which means 2, which means this is the correct target. Okay, this is the third one, not second, this is the third one, this is the index. Okay, because index starts from 0 to, and so this is for the third one over here, 0.1563. okay, now so here I have not taken the second one, I have taken the third one to be correct. Okay, that's why I have said index equal to 2. Okay, now you can also see the shape, because so this is basically 5 and this one is 1, and what you will have to do is you basically have to index, you have to squeeze it. Not here, I'll just show you that this one gets converted, this one here over here, it gets converted to a so this has a dimension. Okay, this is it does not have any dimension. Okay, so if you put shape, it will just come as empty, because it does not have a dimension. It's just a proper number, it's just basically a number. Okay, so what is here, what we are doing here is we are saying reduction equal to mean, and then we are passing out and giving the correct to say your prediction or the correct neuron. So once you do that, what you will get is you'll get a proper to say, okay, let me just have none instead of mean. So I'll show 3 here only. So you can see over here, reduction equal to none, you are getting 1 output. Okay, why? Because you are taking only to say one example. If you had different examples, so this is calculating L of 1. Why L of 1? Because there is only one example, right? If there is only one example, obviously this will give only one particular value, and that's why this is one single value. Okay, so now how to get that? Okay, how to get this particular value? Okay, fine, I have understood with this function, but you would need the output to be calculated from basic tensor operations only, then you will understand. So what I have done, you basically have to apply this formula. Okay, here I have just applied this formula. What is this? This much, this exponent divided by the sum of exponent is the softmax. You just take the log of that, and you take the weight of here. So what I have done over here, I have taken the exponent of that first. This is the top part, exponent over here, the first part over here. Okay, this top part, top exponent. After that, what I have done, I have taken the exponent over here, then I have seen the same thing, I have written a torch.exponent of out, then squeezed it. So what is torch.exponent? So this is the exponent. Okay, if you take the shape of this, let's say just copy everything over here and then take the shape of it, you will see it will come. You can see it's 5 dimensional. Basically it is 5 rows. So basically it is you can see over here, right? So it has 5 rows, okay, and 1 column, or 1 row 5 column, but again this is transport. So but I don't want to confuse you. Okay, so basically what we are doing is we are trying to take only the important. So you do over here a squeeze, so you basically take the same thing. Okay, so once you have that, okay, you save it in temp, and after that what you do, you take the second one, which is this one. Okay, 1.1692, this is temp of 2. Okay, temp is what? Temp is this only. So these basically, if you do the squeeze it, but you can also remove it from here. Let's see if it comes the right. Yeah, if you can. So basically you have to remove, you can just keep like this only. Okay, so you have the exponent over here. Okay, and you saved it in temp, and what you did, you took the second index. So second index is 0, 1, 2, this one. Okay, which was our correct neuron. So you took the exponent of that. So what you did is basically 1.1692, and then you did the summation of all of this. That is summation of all of this. Temp dot sum is summation of all of this. Okay, so once you do that, okay, you will, and then you will take the negative log of that, which is basically from the formula. As you can see, negative log, I have assumed weight to be 1. Okay, weight to be 1 just to make things simple, and then you take a negative log of that, and you can see, you will run over this and you will get the same output. See, 2.2241. Here also you can see 2.2241. So I hope hopefully I have been able to explain to you the basic function, how this works using simple tensor operations. Okay, now we will take a step further and try to get into ignore index. Okay, so there is another way by which I generally don't use, but you can use, but generally it is more suggested to use this one. Okay, this is the giving the class index, but sometimes you can also give probabilities. For example, if you have custom label smoothings, or there are sometimes where you have to say there are two particular neurons. So let's say this neuron is correct but x%, and this neuron is correct 1 minus x%, and so on and so forth. So there are many permutation and combinations. We generally don't use that. We use simple calculations only. Let's say you have ignore index. Okay, how ignore index works, now we will get into some little bit of advanced or a little bit of understanding. Okay, so let's say this was our neural network just as before, and then there were 5 output neurons here, and then there were some other layers as well over here. Okay, so I told you that out is basically a vector of O1, O2, O3, O4 and O5. Okay, what if you don't want to just give 1 1 1 1 1 as weightage? What if you want the weightage to increase? Or ignore index means you have to ignore a certain index. What if I don't care about, let's say, this index? I don't care about what is the output of this index. I don't want to be included in the loss calculation. Now what is this? Again, these are unnormalized logits from the activation from the last layer of the neuron. So these are the logits. What if I don't care about the logit at this function, at this particular index? So what if, let's say, this index is correct and you have said that this index is something I have to ignore, which means in that case the loss is 0. Why? Because this was correct and then you said you ignore this particular index only, which means if you specify any index that needs to be ignored, it does not matter what is the activation or loss of that particular activation of that particular neuron, that activation and the exponent and all of that will not be calculated, will not be used in the final L of I calculation. Okay, L of I calculation you have already seen, which is this one. Okay, no, not over here, which is this one. Okay, so let's go and see an example, because only then it will be clear. Okay, now in this case, when I'm talking about, wait, ignore index, where it is, yes, ignore index. Okay, so when I say ignore index equal to 1, which means I don't care about first index. But my question is, in this particular example, I had said that this one is correct. That is, second index is correct. Index equal to 2 was correct. So even if I ignore index 1, does it really matter? Now, you will only understand this if you understand the theory of softmax plus cross entropy. So this is not very simple. Why? Because in there you will understand cross entropy loss, because in that video you will understand why only the correct neurons output is required and all other neurons output is not required. You will understand only this, only then you will understand. That's why even if you said ignore index 1, the loss did not change. But I told you just now, what if you take the right index and ignore it? So the right index was second, right? So here I had told you, let's go back. Here I had told you that this index is correct, which means this neuron is correct, which belongs to index, not 3, which belongs to index 2. Okay, so what if I do 2 over here? Automatically the loss should go to 0, and you can see the loss has gone to 0. But here if I say instead of 2 I say 3, okay, last I had 1, now I have 3, the loss still does not change. It is the same loss. Even if I put it to 0, it does not matter, it will stay 2.2241. So now generally when we use it, the place that I have used it is in semantic segmentation. Basically when you do not care about a certain, let's say padding pixels prediction, what is the prediction in this particular region, you don't care, then that's why when you use it. But generally I haven't used it, but I had to explain to you the this parameter, and hence I have continued with this. Now again, the assumption still remains that softmax and cross entropy is covered. Okay, now this is the third parameter. So for I have finished two parameters from here. I have finished reduction, which was the simplest, and I have also finished weight, which is also there in BCE loss. Now let's sorry, not weight, ignore index, which was not there in BCE loss. Now we will focus on weight